Let us know the trick in solving magic squares, starting with the 3 by 3 square. Since we have a 3 by 3 square here, we have 9 square units or 9 cells to fill with numbers. And the rules will be, we have to use these numbers 1 to 9 in a way that when we arrange these numbers, the sum of all the rows, all the columns, including diagonals, will be the same. So this is how we do it. At the first row, we have to locate the middlemost cell at the middlemost column. That cell will contain the first number or the number 1. From this number, we just have to move 1 unit up, then 1 unit to the right. But upon moving 1 unit up, in the event that that cell is not inside the square, you have to use this cell instead. Then moving 1 unit to the right, we now have this cell. And this is now where we write the next number, which is 2. Let's continue the same process, moving 1 unit up, then 1 unit to the right. So there goes number 3. So moving 1 unit up, then 1 unit to the right, but notice that this cell is already being occupied by number 1. In this case, we just have to write the next number directly below the recent number. So number 4 will be written here instead. So let's check if this algorithm will satisfy the rules of magic squares. Clearly, we satisfy the part wherein we have to use the numbers 1 to 9. Let's now check the sum of the rows. We have 8 plus 1 plus 6 for the first row equals 15. Second row sum is also 15. And for the third row, still 15. And for the columns, and diagonals. There we go! We really have equal sum for rows, columns, and diagonals. Let's have more notes in doing magic squares. Note that the algorithm that we had earlier would only work for an odd magic square. We have different algorithm if we do even magic square. So this time, let's have a 5 by 5 square. With this, we have to use numbers 1 to 25. Here's another trick. We can actually know ahead of time what the centermost number of our magic square by doing this algorithm. That is, we just have to do the sum of our smallest number and the largest number. Whatever the sum is, we are to divide this by 2. Just like in our 3 by 3 square earlier, smallest number is 1 plus largest number, which is 9. That gives us 10. Divide by 2, which is 5. 5 is indeed the centermost number in that square. Thus, in our 5 by 5 square here, the centermost cell will contain 13. We also have a trick in knowing ahead of time what the equal sum would be. And that is the product of our centermost number and the number of rows or columns. So for a 5 by 5 square here, we would expect that the equal sum would be equal to 65. Just like in our 3 by 3 square earlier, wherein the centermost is 5, and we have number of rows that would be 3, we have 5 times 3 equals 15, so the equal sum would be 15. Let us now arrange the numbers 1 to 25 in this 5 by 5 magic square. So this is the first row, and this is the middlemost column, so our first number will be here. Then we'll move 1 unit up, then 1 unit to the right. And so number 2 is here. Why is 6 here? Because when we move 1 unit up, then 1 unit to the right, this cell is already occupied. Thus, we are to write 6 directly below 5. See, 13 is really at the centermost cell. We indeed use the numbers 1 to 25, but how about the equal sum, which is 65?
Thank you.